In this question, we're asked to draw 2-methyl 4,4-dipropyl octane. When we're breaking down a chemical to draw it, easiest thing to start with is the parent chain. I see that I have oct here, and it's an ane. So that tells me two things. That tells me we have 8 carbons, and we have all of them single bonded. So I'm going to start out by drawing 8 carbons in a row. I'm going to leave some space between each of the bonds so that if I have to add a hydrogen in, I can do that later. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Next thing I see is that we have a methyl group, and it is on carbon 2. Methyl means that there's 1 carbon, so that will be a CH3. Then I see that I have 2 propyl groups. Propyl groups have 3 carbons in them each. 1, 2, 3. 1, 2. We have a little bit more space to just go straight down on the bottom. 3. And I can add in the hydrogens for those right away. The terminal end will have 3 hydrogens. The middle carbons will have 2 hydrogens each. Okay. Last thing I need to do is I need to add in any hydrogens that go with unfilled carbons. So on each of the terminal ends, I need to add in 3 hydrogens. On the second carbon, I need a single hydrogen because it has 3 bonds to carbon. And remember, we always want carbon's bonds to add up to 4. On the third carbon, I need 2. Fourth carbon, I don't need any because it already has 4 bonds. Fifth, I need 3, or fifth, I need 2. Sixth, I need 2. Seventh, I need 2. And there we go. That is the full diagram for this compound. Now, I could write this out another way as well. I could do this with a line diagram, which will often be a much quicker way to sketch it out. I start with 8 points. So remember that when you do your first line, where you put your pen down is actually the first point. The end of the first line is the second. The end of the second line is the third carbon. 4, 5, 6, 7, 8. Okay, we have 8 vertices here. It's the vertices you're counting in the line diagram, not the number of lines. Then I have a methyl group on carbon 2, which will be right here. Methyl group will just be 1 carbon. And then I have 2 propyl groups on carbon 4. 1, 2, 3. 1, 2, 3. And that is another perfectly valid way to draw this diagram.